Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. Hey everyone, welcome back to the podcast. David and I are talking about the Hyperloop transportation technology, the system as a whole. We were actually just chatting offline and wanted to take it onto the recording, but David, you were wondering, like, what does it feel like to be in a Hyperloop system, right? Which is, just like a bullet train, but maybe on steroids. And I guess my thinking there was, well, if an airplane goes like 300 miles per hour, we learned in the episode that Hyperloop goes 700 plus miles per hour. My thinking was that it might just be relatively the same. Like if it's within a system, a pressurized system, then you might feel like I feel like there might not be much of a difference, relatively speaking, compared to an airplane. David, what do you think?
Yeah, I'm not sure because if we zoom out and think about our fundamental physics, even though we're in a pressurized container, what happens if we take an observer in space or something? And so to them, we're still moving faster than we would be a plane. And so I'm not quite sure if this is true, but maybe one of the effects of jet lag is because we're subjecting our bodies to higher forces. And so I don't know if that would have anything to do with it. I would need a lot more experience in the medical field to draw any conclusions there. But I just think it's interesting that with all these new technologies, there's all these new ideas that we need to discover. And then the questions go, how do we even test this out with things that haven't been invented yet? And so I think that's very interesting.
Plus the speed of sound, I just looked it up, is 767 miles per hour. So you're nearing that speed of sound too, right? How much does that have an effect on your body? What would that feel like? And I guess also what systems would you have to implement within that capsule to actually make that livable and comfortable for a passenger? I think that's crazy. I wish we learned a little about what that might feel like in the episode, so stick around for that. But what was your favorite part, David, about the episode, maybe materials wise, technical, or in general?
Yeah, I think one of the coolest things was one of my big hangups was how do we power a giant system? And so if we wanted to move from California to Atlanta, how would we power such a long railway system? And so they've done a lot of thinking and a lot of research into it. And yeah, the answer is passive elements. And so in these passive elements, he was talking about a Halbach array, which is basically a way that you make magnets in a pattern that basically, as you run along some sort of metal, conductive metal, it creates a downforce from a magnetic EMF field. And so that helps you stay up longer. And so things such as that are really interesting things that have been applied other places and now are being seen in a new light in this new application. And so I think that goes into one of your favorite parts, Punith, which is what?
Yeah. No, so what I thought was the most fascinating was their unique business model, where they have a bunch of strategic partners that they give equity or stock options and kind of pitch that vision for the future of transportation. And in that way, they leverage other people's insights, their knowledge, their expertise to build their company up and create even more value or actually achieve their goals. And I thought that was fascinating. And we actually in the episode get into why they do it, but also why Andrea, our guest, believes that other companies don't do it right now and why that might be the next step for business strategy as a whole. But another favorite aspect of mine of the episode was storytelling. I think that communication is imperative in the science space, and it's often maybe not as natural for us engineers to communicate effectively. And so Andrea actually has a very unique background where he oversaw the engineering department, but he also oversaw HR and has a background in media and storytelling. So stick around for that. It's really closer to the end of the episode where he goes into advice on how do you pitch that vision, how do you communicate with others and let your words and your presentation resonate with your audience. So I thought that was very insightful. And yeah, I don't know. I'm about to hop on a plane myself to go to Yellowstone National Park for vacation. So I'm just imagining how that would be different maybe 10 years from now, 20 years from now, if all of a sudden I can make that trip on a Hyperloop system. But yeah, super fascinating stuff. There's a lot to look forward to, and we hope you enjoyed the episode. Let's get into it. Hello, everyone. We are super excited to welcome today's guest, Andrea La Mendola, the Chief Operating Officer of Hyperloop Transportation Technologies, a company changing the way people travel. Andrea has a unique background, which includes studying engineering, software, management, and media. And at Hyperloop TT, Andrea has overseen a variety of departments, including engineering, human resources, and global operations. He's passionate about communications and storytelling, as well as kind of the engineering field as a whole, which makes him a great ambassador for the newest form of transportation in over a century. Thank you so much for joining us today, Andrea.
Thank you. Thank you for having me.
Awesome. So yeah, so let's dive into your story. Punith mentioned a whole different range of activities, but you mentioned in a previous call that it was on a trip to India that you realized the potential impact and excitement for your Hyperloop technology. Could you elaborate on this trip and what you learned about the perception people have for this Hyperloop technology?
Yes, David, that was 2015. We were still at the beginning of our journey in Hyperloop TT. And I remember I was with the two founders of the company, and we visited Hyderabad for a big event. It was like thousands of people attending. We presented Hyperloop, of course, Hyperloop TT, to this very large crowd. And we were on the stage talking about the technology and what it could bring to society. And I still remember, like, it's crazy. Like, after the presentation, we got surrounded by a multitude of people, like asking for autographs and photos. It was like seeing like fans of a rock band chasing their idols, sort of like. And yeah, in that moment, I really realized the impact that we were having on people, and with this project it was incredible. And we were really starting to think that we were able to make a transportation project like very cool for new generations. So something in my mind in that moment like changed, and we really started like looking at the Hyperloop project as a really transformative project and a cool project for the young generation to be part of.
Yeah, I don't think engineers ever have gotten kind of an experience like rock stars. So you might be the only engineers on this planet to get that experience.
I'm sure there are many more, like today, pretty sure.
So what do you think was it exactly about your technology that resonated with so many people? Is it just the fact that transportation just impacts everyone naturally?
Yeah, that's what I will say. Of course, it's the cool, futuristic, and fancy technology, very high speed, sustainable. But I think that the most important thing is really the perception of what this new transportation system will bring to our life. When you really reduce the barriers of traveling, like long distances, faster and better, and how this new opportunity will change your habits and really reshape community. And I think that everybody really understands the impact that Hyperloop will have in their lives. So I think that is really the combination of the cool technologies and the opportunity that really brings in the society. And of course, the sustainability angle. This is a very important thing. Like, it's a green technology. People are very excited about this opportunity to really make an impact in reducing CO2 emissions. And the younger generation are very receptive of technology that have this sustainability angle.
And when you talk about a technology such as Hyperloop, which is almost unlike anything that we've ever seen before, of course, you're going to have a few adopters that are extremely excited from the beginning, but it's going to be an S-curve of getting it. And so how, as Hyperloop, or maybe just more generally, these new concepts, how do you take that first group of people who are extremely excited and continue to build upon that until you get this rock star like following?
Yeah, it's a great question. I think that our model of organization really helped over the years. We have a very unique model of organization. We call it crowdsourcing. It's a crowd-powered organization. We basically, at the beginning, 2013, we did a call to action to every engineer, scientists, experts around the world that wanted to help us. And what we were offering at the time was basically an exchange of your knowledge, participation. We were giving you stock options of the company in exchange. And that built a foundation of a very strong team, very diversified, many different culture, many different backgrounds, people that really were passionate and are passionate about our project that started to collaborate with us. And little by little, we build on top of that community and bring more unique expertise on the table while the product was developed, right? Sometimes when you do innovation, you don't know what you don't know. So you need to be prepared and flexible to find the expert, the specific person that will help you to solve the new issue to really create innovation. And that's what allowed us to really generate this passion and interest around the project by involving the community and supporting us with the development of the technology and the project overall.
Did you already have that network in place, or how did you go about finding those experts where you wanted to expand?
At the beginning was a lot of outreach. It was going to events, educating people about the technology, going to universities and talk about Hyperloop. And of course, media helped a lot all over the place. Talking about Hyperloop, of course, Elon Musk and the fact that he was the one introducing the Hyperloop concept to the world that really helped. He has a huge outreach. And so a lot of people were super excited since the very beginning. And what we did was trying to really add more and continue to push for the message and involve the people all around the globe. We literally travel everywhere in the globe to find the right people and to build the local communities that supported us.
That's awesome. I definitely know that community is so important for that growth. When you have that strong foundation, that's really something that you can build off of. But now we can kind of go into the material science of it all and the technology behind Hyperloop. So can you give our listeners an overview of what exactly Hyperloop is and how it works compared to other transportation that we have today?
Absolutely. I'll keep it simple to start with, and then we can go more in details. So imagine a capsule, that carries between 35 to 50 people, and it travels also almost at the speed of sound. We're talking 760 miles per hour here. And we are inside a tube, from which we remove the air, so that we remove the air resistance when we travel at very high speed. And so the air drag is reduced inside this tube. And on top of that, we add also levitation system so that we can remove also the friction of the wheels. And all of those elements allow us to have a faster, more efficient, safer mode of transportation with very high level performances. On top of that, we have solar panels on top of our tubes and infrastructure, so we can capture energy, produce more energy. That energy goes into power the system. And at the end of the day, on average, we are even able to produce more energy than what we consume. So we are net zero or even positive energy in certain cases. And this is the Hyperloop. It's considered the fifth mode of transportation.
And so now diving more into these specific applications. And so the first part is where it is. And so for Musk and the Boring Company, the focus is underground. And so as you are developing the technology and you're saying things like solar panels on top, that kind of implies that it's going to be on top. And so for Hyperloop technologies, how do you see the where it is, whether it be on top of buildings, just on the road, or underneath the buildings? How does that look like?
So the beauty of this technology, this infrastructure overall, is the flexibility. You can go above ground, you can go ground zero, below ground. You can have different techniques of going underground, from what we call cut and cover. Basically, you excavate enough to place your tubes, and then you cover those tubes up, but you don't need deep tunneling techniques. Or you can go deep tunnelings, really going really underground and excavate and create the boring over tube. So that My first answer is that it really depends on the local environment, the local ecosystem, and the best option for that specific route. Our base design is above ground, is like an elevator infrastructure on top of pylons with the two tubes, one to go and the other one to go back. That's the basic standard infrastructure. And you can imagine this infrastructure being integrated with existing right-of-ways, in some cases like highways or like railway. Of course, the straighter you are, the better it will be, because you can go faster. You want to keep like acceleration, deceleration, and all the forces for the passenger very comfortable overall. So you don't want to have like huge curves. When you have big curves, you just go slower. So it's sort of like a trade-off between how fast you go in a certain point and how much your right-of-way allow you to build the system straight.
So then I guess from the material side, what materials enable this like next generation of technology? You mentioned like removing air resistance and the propulsion, the levitation, like what materials contributed to taking that leap to something completely advanced?
Punith, there are so many materials here that we can talk about. It's
Yeah.
a fantastic world of material science, the Hyperloop, because as you can imagine, we touch so many different industries. We have like the infrastructure world, the civil construction, where materials, of course, is super important. We have like aerospace for the capsule. We have like all the things related to the propulsion and levitation for magnetics. So let me break it down like in some core like material elements. So the first and probably most important one, at least from a cost perspective, is the material of the tube. So today, as the first generation of the Hyperloop, we decided to build it with steel. And the reason why we decided to go with steel is because it's a mature technology. It's a technology that we know very well. We tested it for a very long time, and it holds the low pressure environment incredibly well. And it's also very safe. So there are a lot of good characteristics of the steel. But of course, as a company, we're already looking at generation 2, generation X, like in 10 years. And of course, it's very important to study materials. And so composite materials, ultra performance concrete, all those materials that will create good performances for the low pressure environment, being able to reduce cost, be lighter. The lightweight, of course, of materials is always one of the most important things. So again, it's always a trade-off between the cost and the opportunity and the quality of the material, the technology that is surrounding that material itself. If we talk about our capsule, our vehicle, we decided to go directly with composite materials. And that is the advantage of having a lighter weight compared to other materials. And, when you have a lighter capsule, you become way more efficient from an energy standpoint. So that it's an important materials that we worked with our partners to find the best option for generation 1. And again, we're going to continue evolving and innovating on those materials to continue to make it lighter, smarter, with the idea to all continue adding more sensor embedded in the materials so that we can capture data. And of course, then there is the entire topic of magnets. We use magnets on our system. We have a lot of permanent magnets for our levitation system. The levitation system that we use is called the Indutrack. It's a technology developed by Lawrence Livermore National Lab here in the United States. We license in exclusivity this technology. This technology uses the permanent magnets in a very unique configuration, such as aluminum, copper, to create this levitation effect passively without the use of electricity. And so magnets is an important component, of course, of our product, as well for the propulsion system. So many, the answer is many.
And so maybe we can break it down a little bit. One question, maybe more generally across multiple fields, is that you're always talking about what's next, what's generation X. And so as someone who's already working on like a groundbreaking technology, and so there's already some sort of uncertainty about how exactly will everything work, how can you look ahead 10 years and try to choose materials based off things that you don't fully understand quite yet until you get to like full mass scale production?
Without also knowing the maturity either, right?
Yeah, exactly.
It's an incremental development process. It's an incremental design process where you have very clear your generation one. You know that the generation one fulfill all the core requirements, certification processes. We start from technology that already have a certification framework around, so the generation one can be easily certified. But of course, when you start working on your technology, you already know what are like the things to improve, the challenges that you have. So the teams start working on ideas, and when you have like a very good team that works in multidisciplinary teams and activities, then you start having a lot of new ideas that comes up. And this is the beauty of innovation. And so you start making a list of all those innovations that are come up along your journey. And there are the ones that can be applied in generation 2, or the ones that that you will need probably 5 years to develop, and it will be a generation 5 of the Hyperloop. As long as you always put in context your innovation and you create a path of your product development process. And then the technology little by little will mature enough to be tested, to be integrated, and eventually to become part of the product that you will implement in a specific project.
So then how did you take existing technologies? So for example, in a previous episode, we learned that the fuselage of Boeing airplanes are made of composites. So was that a factor that came into play when you're designing your own fuselage system and or your capsule system? And then how do you kind of take that next step to find just incremental improvements like you mentioned?
Absolutely. And one of the best strategies that we used is create these ecosystem of strategic partners that are part of basically of our development process. We have today more than 50 companies that work with us as strategic partners. They also have a stake of the company, and together with them, we identified the best technology that they already developed in their field. I give you an example. We have an amazing partnership with Hitachi Rail. They developed the traffic management and signaling system for high-speed rail. It's based on a standard called the ERTMS system. So when we started the collaboration with Hitachi Rail, of course, everything was around the traffic management and signaling. And so we discussed, so what would be the best technology to apply to Hyperloop? And after an analysis and a discussion, we decided and we agreed that the ERTMS system was the best one to start with. And we applied basically that technology to the Hyperloop by creating that additional layer of innovation to adapt that existing technology already certified and used in high-speed rail in the Hyperloop. So here, the expertise of our partner together with the expertise of our team that knows the system architecture, that knows the product overall, the combination of those two expertise allowed us to pick the right technology already existing and adapt it to the new environment.
And I think that's great, especially because Hyperloop is sort of like a train system. When you take your technology and you apply it from others, how much could we basically equivalent to first order problems, where it's basically a train in a vacuum moving at fast speeds? And then how much technology can we take? So I guess my question to you is that you have this great system with all these contributors. Why don't you think other companies who maybe are startups or maybe other more mature companies take this interesting approach and getting all these other insights from other industries?
We do. We take insight from other industry. In fact, I think it's one of our strengths is to be very horizontal to many different industries. So we don't consider ourselves a rail system or aerospace or autonomous vehicle. We are a mix of all those. And then we touch so many different industries. I was saying is the civil engineering, including the material science and the control and autonomous vehicles. There is everything related to the passenger experience, and how you bring in the capsule technologies that are good for the passenger to experience a better journey when they travel. So all those different areas are coming from different industry, and sometimes are startups, sometimes are boutique companies that are specialized in one specific topic. Sometimes are big corporations that have the strength, industrial capabilities, the footprint to not just develop certain parts of the technologies, but then also produce it and manufacture it and bring it to scale, which is equally important, right? We need always to remember this is not just an R&D project. This is a mass transportation system that needs to be implemented globally all over the world. So global footprint, huge industrial and production capabilities with maximum safety requirements, a lot of activities that will have to go for operation and maintenance. So all those things creates a very comprehensive and complex ecosystem. As Hyperloop TT, we are sort of the network orchestrator at the center of this ecosystem and connecting all those different dots.
I guess I think what David was asking is like, he was very impressed and I'm very impressed with this business model, but it seems like it's unique in the way where you're giving like stock options to all contributors. I think what we were wondering is, why don't other companies do that, in your opinion?
That's a great question. And I think that one of the things that we are start promoting ourselves is to use this model for other startups and other organizations to create open innovation, to bring their startups to the next level. It's a model that can be implemented. For sure. And in fact, Harvard is teaching our organizational model to their students, to their master students, and they sort of named us as the next generation of companies, how you build companies in the 21st century. So I think there is this impression that more companies over time will use this methodology to boost their innovation and to scale up from startup to full mature companies.
Yeah, there's a lot of power in having that network is something we've also realized in our own niche too. But kind of taking it back to the science, I was just wondering if you could dive into that magnetic levitation system a little bit more. That was super fascinating to me. You mentioned, I think, aluminum and other metals. Can you talk about that? And then also maybe how much electricity is needed? And so that's more in the propulsion system, right? So can you just talk about that as a whole?
Absolutely. So the levitation system works in this way. I'll be very high level here, but in principle, we have those permanent magnets in a very unique configuration. This configuration is called the Halbeck array. Halbeck array is basically this sequence of permanent magnets, one next to the other, to form this array with different polarization. This Halbeck array has the unique characteristic where when moved on top of a conductive surface, example aluminum, if a movement is in parallel to the surface, the faster you go, the more electromagnetic field it generates in the relationship between the magnets and the aluminum. And this electromagnetic field points down because of the specific configuration of the Halbeck array. So by moving on top of this conductive surface, you generate basically a lifting force that pushes the Halbeck array up. So imagine now that you have multiple of those Halbeck array, like at the bottom of our capsule, inside what we call the bogie that contains the different elements of the proportional levitation, the suspension system, and other elements. So you have like those bogies that have those Halbeck arrays, and when the propulsion system moves the capsule forward, we'll start creating this interaction between the Halbeck array and the aluminum to create this lifting force. So here, what is important? It's important the type of magnet that you have in your Halbeck array, also the way that you dimension it, the way that the shape of the magnet. So there is a lot of design activities around the magnets. Also the type of rare earth materials that you have in your magnets, the specific type of permanent magnet that you pick, a lot of different elements. And the other very important one is the conductive surface. So our company decided to choose aluminum. And it's not like just a plain aluminum. It's a little bit more complex, that there is a layered aluminum. But the goal basically for that specific materials is to maximize the relationship between the lifting force that you create, the reduction of the drag force that it produces in this let's say, a relationship between the magnets and the aluminum, and the cost. So of course, you want to have a very cheap material that is very conductive, so that it creates a very good lifting force. All those elements together in a trade-off analysis will bring you to the best possible materials and the best possible configuration of all those elements. And when it comes to propulsion system, we use a linear electric motor. In our specific case, the first generation will implement a linear synchronous motor, very high efficiency. A linear synchronous motor is a very mature technology in the industry, is being used in many different transportation systems, and usually reaches like 90% efficiency in certain cases. So it's very, very high level, and the combination between how you design the integration of your propulsion system with the levitation system will give you the optimized product, basically, to consume the minimum amount of energy possible within that environment.
That's awesome. And so when we talk about the next generation for these magnets, is innovation really driven around maybe new types of magnets, or is it mostly that design process you're talking about identifying the best parameters and the like the spatial arrangement?
It's both. Definitely, there is an optimization process where you continue working on the design, refine it, test it, validate it, and implement it, so that it's a continuous process that it goes over forever. As long as you continue innovating, you will always improve a little bit the efficiency. And of course, there is a specific component of materials. So one of the elements that it's great to investigate is how we reduce the rare earth materials in the magnet, so that eventually we'll be able to have magnets that don't require rare earth materials. So this is a longer term strategy. And of course, we are not the expert of the production of the materials of the magnet itself, but we find the best companies on those fields and offer them the possibility to innovate and find solutions to reduce those rare earth materials and to find better, more performing type of permanent magnets.
Interesting. Okay, so I would love to learn more about like the linear electric motor. I actually don't know too much about it. You mentioned linear synchronous as well. Can you just talk about what exactly that is and how that helps contribute to reaching these speeds of 700 plus miles per hour?
Absolutely. So also here, I'll stay high level. So a linear synchronous motors has two elements that contributes to the motor itself. So you have magnets. In our case, we put the magnets in the bogie. So we have a set of magnets, permanent magnets as well, that interacts with an electromagnetic field that is produced by coils that are on the track. So you have those coils that allow you to pass electricity across, and by producing this electricity, you basically pushes the magnets that are on the bogie forward. And this is like all controlled by a control system. There is a lot of software engineering activities where you program the specific control system to allow the proper flow of electricity in the coils that interacts with the magnets on the bogie. There is a specific component of the bogie that is called keel. There is like a vertical element that keeps the magnets together, and that part interacts with the coils on the track. And the flow of electricity, like a wave, you can imagine, pushes those magnets forward.
And so it seems like that's like the only active part. It sounds like the rest of the design is passive. And so how much energy does it take to get up to those 700 miles per hour? And how can we compare that to maybe like a car or a plane?
Yeah, so the most important thing to consider is the overall energy consumption, right? Because it's always the combination of the different elements that produces the overall energy consumption, and then you can offset with the energy generation or recouping energy, which is also an important element. So let me give you a general overview of our energy consumption. And I'm gonna go a little bit, let's say, numbers in a range, because I don't wanna be too specific here. So we have our vacuum system that it consumes between 20 to 30% of the electricity to create the initial vacuum. Then to maintain the vacuum, it requires way less. It's just maintaining the low pressure environment over time. Then you have like the propulsion system. We're talking 60, 70% of the electricity overall of the system. And the remaining, it's between like the different control element, traffic management, the capsule systems, the infotainment, all the elements that are inside the capsule. So as you can imagine, like the propulsion system is one of the elements where you spend more electricity in. And that's where it's very important that when you define the best technology possible, you consider first, can I make it very efficient? And here the linear synchronous motors, as I was mentioning, can reach a high level of efficiency. Can it reach very high speed? Because of course, if you have a very efficient motor, but the motor cannot go more than 300 miles per hour, then you don't have the technology that you need. So you need to combine those two elements. And then, of course, there is a component of, can I recoup the energy? So like, for example, we have a huge amount of recouping the energy through the braking system. So it's a loop of energy that needs to be considered. So it's not just how much the propulsion system consumes itself, but the entire cycle of energy that needs to be considered. And you want to reduce the heat dissipation, of course, and all those different elements. So as I was saying before, it's always about the design of the overall architecture that makes your system efficient. To answer your question about a comparison with other mode of transportation, of course, it's always difficult to make those comparisons because we are talking about different mode of transportation. It would be unfair because each of them have different performances, have completely different environment, et cetera, et cetera. But let me tell you something that is very important. There is the principle of the Hyperloop itself. One of the biggest consumption of energy in transportation is the air resistance. The vehicle, when it goes, especially at high speed, encounters a huge resistance from the air in front of the vehicle. And the faster you go, and the more this becomes a factor, and it's an exponential factor, it's not linear. So when you pass from like 200 miles per hour to 300-400, you really have an exponential curve. So there is a limit of many mode of transportation after which it becomes very energy intensive to push all their air forward. So that's the beauty of the Hyperloop. Hyperloop removes from a design standpoint the problem of the air resistance, and that's why at a higher speed you don't have this exponential curve anymore. You have a curve that tends to go stabilize with the speed, and that's the big innovation of the Hyperloop concept. And so high speed are not impossible anymore from an energy standpoint. And you can talk about an airplane, but airplane, when in order to find a similar condition, they have to go like 35 feet in the sky. 35,000 feet in the sky to get that level of pressure and the level of aerodynamic resistance to go a higher speed. And so we bring the speed of the plane basically on the ground level.
Okay, I'm going to change the topic a little bit, but it's still important to material scientists and engineers, and really all scientists and engineers. It revolves around storytelling. So I feel like one key aspect that we didn't quite emphasize with this business model is the importance of relaying your vision and telling your story and pitching it in a way where other partners would want to invest their time and their money into your vision, right? Like, if you can give them stock options, but if they don't believe in the company, then that isn't really worth a lot to them. So how did you go about that? Do you have any advice for storytelling when it comes to technology and science and engineering?
Vision and a specific mission is core. You need to identify early on what is your mission for your company. In our case, always been like how we can create product, a Hyperloop system that it can be the next breakthrough in transportation that brings like a next level of safety, next level of sustainability, next level of passenger experience. Very important. Remember, we are moving people. People are live their lives by experiencing things, and we want to make sure that when they experience the Hyperloop, they have a good feeling and they can have many kind of experience based on what that's their preference. So in general, it's important always to identify your mission early on. And then of course, how you communicate your mission, it's critical to all the stakeholders. And you need to consider since the beginning, who are the key influencers in your industry, your key stakeholders, the people that you really want to involve early on, because by having those people early on or those entities early on, then you can convince others to join. It's sort of like, it's a little bit of a chess game. Like you make a move knowing already what are your next 3-4 moves, right? And if you know that certain categories will help you to unlock other categories, then you try to bring those categories in earlier. So you play with those different elements. And in our case, it was very important to have a buy-in from strategic partners that had the competence already in the transportation industry. So the overall ecosystem was seeing Hyperloop a very solid play with the strong partners in the mix, so that it's not just about us, but is a movement, is a group, is an ecosystem working together to make this a reality.
Yeah, I think you did an excellent job, like explaining why vision and getting people to buy in is like so important. And so I guess our question for you is, what is your vision for Hyperloop in 10 years from now? What, if we were investors, what are you getting us excited about to join on and give our ideas and our knowledge to you?
I would say a few things. First and most important, imagine like changing completely the paradigm of traveling. Like now you can really move from a city to another one instead of like 2-3 hours in 30 minutes. So now it becomes a commute. You want to grab a coffee in another city, like you can do it. You want to live in one place, work in another, or study in another place, it becomes easier. You really change the dynamic of your community. You really redefine how cities themselves are taught. So suburban environment becomes different from city center, because now you can create a satellite city, a suburban environment way farther from the city center, but still feel they are very close with each other. So this element of reshaping our communities and our society. This is one point. And so to take this point to a little bit the next level, imagine like a metro system for the United States, where all the city center are connected through Hyperloop, and you can move literally across the United States with this very fast metro system that covers the entire continent. That's one topic. The other topic, which is equally important, is sustainability. We are facing as a society a huge problem, CO2 emissions, and how we can have systems that are more efficient, a system that consider the production of energy embedded in the overall infrastructure. How we can have a product that solve the issues that we are already facing and we need to solve as soon as possible. And I see Hyperloop in the next 10 years being at the forefront of this fight against the CO2 and against the climate change, against the challenges that the change of weather will bring. Like we have a lot of extreme weather condition lately, many places in the world. Having a resilience mode of transportation will be indispensable. When you start having like hurricanes or like floodings or things that could block your current mode of transportation, current network of systems, you need to have something resilient. And Hyperloop, because it's encapsulated in the tube, makes it very resilient against the external weather conditions. So all those factors need to play and define today to be ready as a society in 10 years, 15 years, when we're gonna encounter those issues and we need to adjust. We are very good as a society, as a humans, to adjust to the condition, right? But now we have a lot of technology and we need to leverage as much as possible this technology to be ready in 10, 15 years.
Absolutely. Well, you got me hooked. So if you want me to be an investor, like I got you. But I guess taking that the next level, what are like the main challenges right now that is keeping Hyperloop from being mainstream? Is it just like infrastructure related, adoption related? And what does that timeline look like for when people will be able to start traveling around the world in a Hyperloop system?
Yeah, absolutely. Let me start saying that we need to be aware that create a new mode of transportation requires time. We cannot create a new mode of transportation like we create a new cell phone, right? There is a lot of safety and certification related components. Like it needs to have like a longer design process in order to be successful. So that's the first consideration. Second consideration is that this product needs to be certified, needs to be regulated. So of course that framework becomes very important, needs to be ready by the time we implement our system. So as a company, as an industry, we're working with the different governments around the world to create that regulation framework, that certification process in order to be ready for the global implementation. And also that takes time, but it's normal. It's a process that every industry goes through, and that's what we are doing. I will not necessarily say anymore, it's like, if it's happening, it's when it's happening. And your question is right. So my best estimate will be by 2025, 2026, we are going to start having the first couple of operational systems up and running. That maybe a smaller segment, shorter segment that will allow you to show every day the use of the technology, moving passengers reliably, safely, and always with the right availability of the system. And from there to the next 5 to 10 years, then you are going to start seeing like this product really being implemented globally. This decade is the decade where we are going to be able to showcase already the first couple of routes. And then in the next decade, I see really the expansion of the Hyperloop around the globe.
And I guess maybe my last question is that in the next 10 years, if we get people, that's great. And I can see that's the focus. But when we think about how we live our lives and how we want to do things, a big part of it is shipping. And so for Hyperloop, it's not only going to connect each other, but I guess one, do you think it would disrupt the shipping? So now I don't have to ship something from California to Atlanta. I can just go there. Or do you think it would even make it even better? And now instead of shipping over a week, now it can ship over a day. And does that what 20 or 30 years looks like?
Great question. Absolutely. So Hyperloop is great, not just for passenger, but for freight. And we have in our company two different type of freight that we can carry. We have the light freight, so let's call it the ULD, air cargo, the small ones, the packages, and we can move those goods inside the passenger system. So basically same capsule with a different configuration inside. And so we can optimize the corridor that we build for passenger also for those type of freight. And then we have another product that we call Hyperport, which moves the shipping containers, sea containers. So this is another type of the goods that we can move. And absolutely, as you said, it will definitely disrupt the industry as well, because now we're going to start having the opportunity to move goods way faster for longer distances. So you can imagine even very, very long routes to bring from one continent to another one, certain goods that today through boats or through other modes will take a few weeks to go from a place to another one. So absolutely. And of course, as you will probably imagine, it's a little bit easier from a regulation and certification standpoint to have the system up and running. So there is a good chance that it will speed up quite a lot in the next couple of years, the movement of goods through Hyperloop.
Yeah, that's what I was thinking was you could use them, or you could use packages more as the dummy testing right before actually having human passengers. So it seems like that's actually potentially a next step before even a passenger travel, right?
But Punith, yes, let me say though that when you design a new mode of transportation, you need to start from the passengers, because there is a more complex design, has more constraints. So if you start from something that is way simpler, then adapting that to the passenger, it's more complicated. If you do the opposite, it becomes easier. So that's why we decided as a company to really focus on passenger when we started the development of the technology, to have all the right technology and the right architecture to be able to carry passengers. And now there are activities to adapt it to freight is much easier. I think we are so happy that we made the decision early on, because now our life, it's way easier than how could have been like the opposite.
So to wrap up this episode, what would you like our listeners to take away from this conversation in Hyperloop technology? And especially, what is the impact material science can make on this form of transportation?
Material science will really disrupt many industry in the years to come. So it's one of the most exciting industry that I can see really changing a lot of things in our lives. And new computing power, new technologies that allow you to simulate material science will literally give us the opportunity to have a leapfrog in a lot of materials, and that will impact and there will be a spiral exponential innovation process, because materials is basically the foundation of most of the things that we have and we do. So by multiplying the capability of that foundation, you will multiply exponentially everything that is on top of that. So I really encourage like scientists and engineers that like material science to really keep innovating in that world, use the most innovative computer technologies. Now quantum is coming, and quantum will disrupt a lot of industry as well. Use those technology, learn how to leverage those computing technologies to analyze, test, simulate new materials that can be applied to so many industries. This is going to be a game changer. And please, when you do that, always think about the sustainability angle. That's very important. Materials that are more sustainable for the environment. So if I have to leave it with a message, is like, let's work all together on sustainability to make sure that the scientists and the future scientists and engineers will put that at the center of their innovation. It's core, it's very important.
Yeah, thank you so much, Andrea, for joining us. I feel very motivated and very happy that I chose this path of material science, and it was an absolute pleasure having you on the show.
My pleasure. Thank you. Thank you for having me, and I look forward to continue those discussions with you guys.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.